Hi everyone, my name is Parthvi. I work as a software engineer at Red Hat, working on OpenShift developer tools. I live in Bangalore. I have a very cute 8-year-old Labrador. If you're interested in puppies, maybe we can discuss later. I can show you her. All right, so today it seems you can define almost everything as code, from your infrastructure to your CI pipelines to your networking. Everything can be defined as code. And now, with the help of Devfiles, you can also define your development environment as code. So at the core of it, Devfile believes that a development environment should be an immediate and on-demand experience for the developers, so that developers can directly jump into coding and building their application rather than being stuck in setting up the development environment. That is necessarily not the case. There are a lot of times when we're stuck with setting up our development environment. Sometimes it takes days to just get started when you're working on a new project. And it has become normal for applications to be cloud native these days, but that is not the case for our development environments. And because of this, our developers are left behind with configuration overhead and regular maintenance of their development environment. Different projects require different toolings, and these different tools require a different version. So switching between different projects is not always easy. So I was showing this presentation to my colleague yesterday. I just wanted to run it by him. And he mentioned that there was a point in his career where he had separate hard drives for separate projects. So when he wanted to work on a particular project, he would just insert that hard drive and get to it. Luckily, he was working at some hardware-related company, so it was easy for him to just get a hardware and work on it, but that's not true for all of us. Diverges between different team members, and this inconsistency makes it difficult to collaborate on projects. And that's why we often hear the phrase, "It works on my machine," but maybe it only works on your machine. Well, with the evolution of DevOps, we also hear "works on my container" more often than not, but that's a problem for another day. We're not going to discuss that today. So another problem is related to scalability. Now, during an application life cycle, we've often come into cases where an action is very compute intensive. Let's say you've got to run an E2E test, but it occupies a lot of your CPU or maybe memory. With the Devfiles, there is a chance to modernize this. You can use the classic benefits of cloud, which is speed and automation, and apply it to your development environments, so that let's say if a cloud vendor is using Devfiles, they can provide an action-specific development environment with a single click of a button. We'll see what vendors soon. So with development environments living in the cloud, it is possible to never slow down a developer. So we have a problem to all the solutions that we discussed with the help of Devfiles. We've got a solution to the scalability problem, solution to providing an on-demand and immediate environment with the help of Devfile. Now, all right, where was I? So at the core of it, Devfile believes that a development environment should be short-lived and purpose-built. So you don't need to continue updating your development environment. You can just start a new development environment whenever maybe you switch to a new branch or switch to a new project without conflicting dependencies between your old and new project. All right, so now this is to introduce Devfile to you. Devfile is basically a YAML file which lives within your source code. This is a very simple example. So the classic Devfile, it looks like devfile.yaml. That is the standard name, but depending on the vendor who uses the Devfile, this name can change a little. So far with me, any questions? Devfiles, no? All right, okay. So the most basic thing there is, we've got metadata, which talks about the data or the data about your Devfile. So in this case, the most basic thing you can do is define a name for your Devfile. Schema version is the Devfile spec version that you're using. In this case, it's 2.1.0, but we also have 2.2.0. Next, you define your components. So we've got components, commands, and metadata. Those are the three main things. Components, so most basic one is container, that is more commonly used. It's basically container configuration that you define. We've got an image, which is your container image. You can also define endpoints and things like that. We'll take a deeper look at that in a bit. Then you've got commands. So here we've defined a very basic command line command, which will build a binary from main.go. And there are other things as well. We'll take a look at that in a bit. So you can either write your own dev file, or let's take a look at that later, or we've got a registry. So it's similar to image registry if you've looked into Docker Hub or key.io or whatever. It's similar to that. So this registry, this is the dev file registry. I hope the image is clear. So we've got a lot of languages here. Maybe we can take a look at the Go registry. So we've got Go runtime. Yeah, you'll see the whole dev file that your application will use when you download it. So you can think of it like a Docker file. This is where you define your dev file. This is all the metadata. So like I mentioned earlier, we've got different, so this talks about the different versions of Go dev file that are there. We'll take a look at that in a bit. But anyway, so you've got this dev file registry that you can define. Apart from that, you can also define your own custom registry. Maybe if you want something more secure, you can set up your own private registry. We've got documentation for that. But this thing should work fine. In most of the cases, it should work fine out of the box. But maybe depending on project, you might need to make a few changes here or there. All right, so, okay, and we've also got this dev file builder. So a colleague of mine is working on providing a UI interface for building the dev file. So let's say I've got a command, and I will try to recreate the dev file that we saw earlier. So I'll name it build, go build main.go. We'll select the default working directory. We don't have a container, so I'm going to create a container. We'll call it runtime. It will use the Go image. We'll just go with latest for now. I can put in memory request, maybe this. You create it, and then when you go back to YAML, you have a very basic YAML. It doesn't have metadata, but that's fine. So this is kind of a UI interface. It's a work in progress, but it is a good starting point for getting started with the dev file. Now, dev file is, since it's a configuration file, there are a lot of vendors who use dev file. So dev files can be used to set up a remote IDE for you. It will be a remote development environment where you can simply start coding. You don't need to set up your environment. You can just start and run a few commands and it will work for you. So Red Hat Dev Spaces, Amazon Code Catalyst, JetBrains Space, they use dev file to provide you a remote IDE. We've got a CLI tool called Odeo, which would help you run your applications on the cluster. So it kind of provides you a development environment on the cluster, which is what we're going to take a look at today. I work on Odeo, so it makes sense for me to showcase that. Then we've also got a few IDE plugins. There is OpenShift Toolkit, which is available for both VS Code and IntelliJ, which also does the same thing. It uses dev file to help you run your applications on the cluster without diving into the cloud native complexities of the system. So for this demo, I've decided to use Odeo. Now I'm going to do a very classic workflow where I'll download the dev file from the dev file registry. I'll use a very simple Go project, which is a Hello World HTTP server project, and I'll use the dev file to run it on the cluster with two simple commands. So the first thing we'll do is we'll create a directory. It's a completely empty directory. I hope it's visible in the end. It's visible, no? Yeah, okay, cool. All right, so we'll first run Odeo init, which will provide us a list of languages to select from. I'm going to go with Go. You select the project type. In this case, it's only Go runtime, so we'll just go with that. These are the different versions of Go dev file that are there. You can think of it like different version of images. So in this case, these are different version of the dev files. we'll just go with the default one. Okay, so it downloaded the dev file for us from the Devfile registry. So when you install Odeo, Odeo is a CLI tool. Sorry, I did not give a context on that, but Odeo is a CLI tool, and you can simply run the binary of it. As long as you have a cluster and your application, it should work. So we've downloaded the dev file from the registry. You can see that it shows a configuration. So this is a container runtime which is present inside our dev file, the one that we saw earlier in previous slides. We're fine with the configuration for now, so we'll just hit enter. Now, since I don't have a project to begin with, I'll just download the starter project that Devfile provides. So in case you don't have a project to begin with, you can simply use the most basic stubs that are here. Sorry. We'll use, so when it says component name, this is mainly the Devfile name. We'll see that. We'll use the default one. I downloaded the starter project, and when I see it downloaded Devfile and all the necessary projects, all the necessary files that I wanted for my project. Now let's quickly take a look at Devfile, but a little deeper look than we did before. So this is the metadata that I was talking about earlier. This is the version of the Devfile that we selected and the name of the Devfile. Then we've got schema version. So this is the Devfile schema version. 2.2.0 has more features than this one, but this is the default one that we use. Then we've got starter projects. So earlier when I selected the Go starter project, it was cloned from this particular repository. Yeah, this one. Next, we'll take a look at the more important parts of this Devfile. So we've got a component. This is a container component and the most basic one, but there are also a few others. We can take a look at that after the demo. So we've got container. You define all the container configuration here. You can define endpoints, which your application might need. So our Go starter application, it runs the server on and listens to this particular port. So we've got this. You've got image. You can also define memory limit, memory request, same thing for your CPUs. You can define arguments. There are commands as well. Then this container is called runtime. So this will be the name of the container when it actually is deployed, maybe inside a pod or inside a pod. Then there is a thing called mount sources. Now this is specific to Odeo. It's present in the Devfile schema, but the way Odeo interprets this is it tells Odeo whether it should mount the local files to the container system. So we've got that. Then we have got commands. So here we have an exec command which will run the command line commands inside container component runtime. You can also pass environment variables that you want to use while you're running the command. Then you can mention the working directory, the directory from which the command should be run. This is the ID of the command, so this has to be unique throughout all the commands. We've got another command which will use the binary that was created by running this go build main.go. So it will run this main binary inside container component. You can the same thing as before, working directory and ID. So there is this thing called group. Now it's optional, but in case of Odeo, we like to use it to know which command should be run first. So if there is an install command, we'll want to run install first, then you run the build, and then you actually run the binary. So there is that. Next, like I mentioned, we need a cluster to run our application, and I'm using a local Kubernetes cluster that I provision with Docker Desktop. So the next command I'm going to run is Odeo dev. So Odeo dev, the thing that it does behind the scenes is it will create a few Kubernetes resources for us. So it creates a deploy and, my bad. Okay. Right, so it creates a deployment which uses the configuration of container runtime that we had defined inside the dev file. And here we've also got a service, KCD demo. So once this is done, once our pod is running, it will sync the files from your local system to your container. Then it will run the build command that we had defined. Once the application is built, it runs the run command, which will start the server, and it will wait until the application is ready to start receiving requests. Once that is done, it will port forward any request coming into 20,001 to the container 8080. So let's say when I curl this particular URL, it says hello, which is the response from our application. Now, another good thing is, let's say I want to modify this application. I want to change the message to maybe, where did we go? Okay, let's say I want to say hello world. So as soon as I hit save, this is still working, but audio detects changes in your local file system, and it would, right, so if you see here, it detected that main.go was changed, and it would again run the reconciliation loop. It will check if the resources are still running, it will sync the files again, and run the build and run commands again, and it will wait until the application is ready again. So if I curl this URL again, it says hello world. So I didn't have to set up my development environment. This was a Go project, but let's say if it was Python, I wouldn't have to create a virtual environment and install dependencies and things like that. I can simply rely on the Devfile and this tool and set up a quick environment, and I can directly get into developing my application. So now that I'm satisfied with this, I'm just going to hit Control-C, which will delete the setup. It will delete my development environment. So while that happens, there is one more interesting thing that I'd like to show. So with the help of same Devfile, you can also run your application on Podman. So you don't need to modify anything. You can simply, all you need to do is do audio dev and provide the platform Podman. Now this feature is maybe specific to audio and OpenShift toolkit, but depending on your tool, you can provide as many features as you want. So this, I think it would take a bit of time. Well, it's ready. Behind the scenes, it creates Podman, PodLS. Now, the reason we were able to make it work on Podman is Podman does support Kubernetes-like manifests of Pod and a few others. So we were also able to make it run on Podman. And if it does the same thing, it deploys a pod, it builds the application, runs the application, and we can pod forward. So when we call it, it prints the message. All right, so that was it for the demo. Now I'll quickly like to show you other commands and components that are supported by Devfile. So we saw the exec command, which you can use to run your command line commands, but there is also this command called apply. You can define your Kubernetes and OpenShift manifests within the Devfile and use the apply command to apply them. So you can also define a Docker file, and it will build an image for you. Well, your tool would have to do it, but Devfile can pass on that message to your tool. Then there is also a composite command, which is a composition of both exec and apply command. You can run this both in sequentially or parallel. There's that. Then there are different types of components. So we saw the container one, but there is also image, where you can specify the Docker file to build this particular image from. You can define Kubernetes and OpenShift components. They're basically the same, but since this is a Red Hat project, we also wanted to focus on OpenShift. So we have a soft spot for OpenShift. So this there, but you can define your Kubernetes YAML, which will be created or by the tool. Then there is also one for volume. So you can just mention a volume component, and it would create an maybe ephemeral or non-ephemeral volume depending on what you specify. So okay, we already covered this. Next is, right, so we've talked about why Devfile can be helpful. We've also seen the demo. Now I would like to quickly show you how you can build a tool which can understand the Devfile. It's a very short thing. Let's see. So we've got a library. Is the font visible till the back? Or should I increase it a bit more? Good? All right. So the starting point for this thing, for this using this library, is this function called parse Devfile and validate. This function will take a few arguments. Now you can define the path where your dev file is located and a few other things. You can pass this argument to this function and it will return a dev file object. So if you see here, this is going to be your hero or shiro for the tool. So you've got dev file. Now you can use this dev file data to get all the components that are inside your dev file. You can filter out these components depending on the attributes or component options. You can also get commands based on commands. Then there are also, where did we go? Yeah, you can update a component. It's a very simple tool. You can just perform a few crude operations on components and commands the same way as it's mentioned here. We've also got a few functions that can help you interact with Kubernetes object. So there is a get containers function which will give you the slice of core v1.container which you can then use to generate deployment. So Odeo mainly deploys a deployment to actually run your application on the cluster. So once all that is done, you can write the updated data to your dev file with write YAML dev file, and I guess that's mostly it. I'll go back. Yeah, all right, well, that's it for my talk. So this talk was very much inspired from a talk given last year on cloud native regex on accelerating development with Devfile format. And apart from these are the reference links that you can select to learn more about Devfile and Odeo or other tools. Thank you.
So what Devfile is essentially, what is it actually? Because I can use Docker compose file and create an environment and I can do my development stuff, everything inside there. How is it different?
So with the help of Devfile, if you follow specifications that are defined in the dev file, you can use the same dev file to run your application or set up a development environment on the cluster, on Podman, or you can use the same dev file with another tool, let's say Red Hat Dev Spaces, or you can use a single dev file to work with all the different vendors that are possible. Maybe it's possible with Docker Compose as well, but is that? Okay.
Yeah, that's what I was saying, because if I'm developing something, all I care about is I need an environment where I can work in. And if Docker Compose does that, then how Devfile is different. I wanted to know that, so yeah.
This one would,
yeah. But essentially, I want a development environment. So
I mean, if you're developing a cloud native application, it makes sense for you to work in a cloud native environment. So in this case, Devfile can be helpful. Yeah, but thank you for answering the question. Yeah. Odeo is similar to Scaffold, but Scaffold has its own scaffold.yaml, and I don't know if that particular config file is used by others, but we're trying to make Devfile more use. I don't know. I mean, we're trying to not make Devfile just another configuration file, so we're trying to keep it more generic. But yeah, Scaffold and Odeo and Garden and all those are similar tools.
So I've used Scaffold before. So this thing has something around development containers, right? Special containers for development alone. So that sort of thing.
I mean, this was a normal deployment. It's if you're asking specifically for Odeo, we have this tool so that you don't need to learn about deployment services and all the Kubernetes. We abstract those away.
Okay.
So behind the scenes is basically a deployment and a service, but it just uses that container configuration you mentioned in Devfile.
Okay.
So that will be translated to core v1.container of your pod configuration. Okay. Yeah. Yes, we do support, right. So we do support debugging. You can also do debugging. You can run test cases. So earlier, I think in one of the VMware, the second talk that was given, they talked about inner loop and outer loop development cycle, right? So inner loop is basically something that developer does on their own machine and that. But we've also got, so debugging would be a part of it, but we also got this feature called deploy, which lets you deploy your Kubernetes, which lets you run your outer loop deployment cycle. So let's say if someone from your team provides you with a dev file and it has Kubernetes and configurations present there, you can simply run that dev file and it will set up a whole
I mean, how is that different? That also has this remote environments and stuff, right? Gitpod.
Git pod
Gitpod
and
and DevPod. So these are
so DevSpace,
sorry.
yeah, DevSpace, Red Hat DevSpaces does use Devfile.
Just hit
Devfile.
gitpod.io.
Gitpod.io.
Same thing. It's a company. I'm saying it's just a name. Whatever it's a YAML file at the end of the day. They have similar. That is there. But those are vendor specific. You have something called devpod.io as well, which is open source.
DevPod.
Pod.io.
Okay. Devpod.io. Okay. Okay.
I guess this is a different website, but yeah,
This one?
a little similar. Yeah.
Okay. Development environment is good. Okay. But I'll take a look at that.
Sure.
Thank you.
Thanks for the good tool.
Okay. Right. So this is the Amazon Code Catalyst.
So, is Devfile developed by Red Hat? Like, is
Yeah,
it
we
maintained?
do development. So major development is done by Red Hat, but we've also got contributors from Amazon because Amazon Code Catalyst uses it, and maybe some from GitLab as well. They're
Okay.
experimenting with Devfile. So
Nice, nice.
right. Thank you, everyone.